I'm now going to lead you through some simple model building in the mastan structural analysis program. And if you haven't already, look at the other video that I've posted to see how to download and install and run the mastan software. So I already have mastan open on my screen here, and I get the blank sort of modeling window. And what I'm going to do is walk you through building a simple model of a vertical cantilever similar to the Eiffel Tower, so that we can see how the bending moment diagram is generated and the deflected shape as well. The menus that operate mastan are up here along the top, and to build a model and analyze it and view results, we more or less move from left to right across the menus. We can start with geometry. The first thing we have to do is define nodes, and you see when I choose define node, down here at the bottom I can enter x, y, and z coordinates. So I'm going to put the first node at 0, 0, 0, the origin of our coordinate system. And I'm going to add one other node at an x coordinate of 0, a y coordinate of 10 feet, which is 120 inches. I'm doing everything here in inches and kips, thousands of pounds, and a z coordinate of 0 as well. So I click apply, which I have to do after every command, and I see that my second node has appeared up at the top and my first node is down here at the bottom. The next thing I need to do is to define an element, and I can do that by clicking the two nodes that I would like my element to connect, and then clicking apply, and you see that a dashed dot line appears. We need to give this element material properties and cross-section properties. So under the properties menu, we can define a section, and the section properties that we have to define are the cross-sectional area. I'm going to put in 3 square inches and a moment of inertia of 1 inch to the 4th here. The rest of the entries can be left as they are, and we click apply. So we see here that we've successfully defined section 1, and we now need to tell mastan that that section should be attached to the element, that this element we've defined should have those section properties. I choose the attach section command, select the element to which I want to attach the section, and click apply, and you can see that the line type changes to a dashed line here. The next thing we need to do is define the material of which this is made, and we're going to define a material that's basically like steel. So define material, and then down at the bottom again we have to enter E, which is the elastic modulus, and I'm going to enter 30,000 kips per square inch, which is a typical value for steel, and I'm going to click apply. So success, I've defined a material properly here. I now need to tell mastan that that material property set goes with the element that I've already defined, and so that's under attach material, select the element, click apply, and now that line, the element has turned into a solid line, indicating that it has both section properties and material properties defined. The next thing I need to do is tell mastan how the structure is loaded and supported, and that all happens in the conditions menu. Conditions define fixities, and then selecting node 1. These checkboxes along the bottom tell us how the structure is supported or restrained at the node we've selected. Displacements in the x, y, and z direction, and rotations in the x, y, and z direction. I want to select all of these for my little model of a vertical cantilever here. Click apply, and now you see that some red arrows have appeared down here to indicate that some fixities or support conditions have been applied to the element. I need to load it. Define uniform loads. Select my element and input a force here per unit length in the horizontal direction. And the value I'm going to put in is 0.001. That's kips per inch, so thousands of pounds per inch. I'm going to click apply, and you can see that the green load indicator has appeared here with an arrow pointing to the left. If I wanted to make it pointing to the right, I could put a negative sign in front of the load and click apply, and the direction of the arrow reversed. The model's ready to analyze. So I go to the analysis option, I click first order elastic, which is the only kind of analysis we're going to be asking you to run in this class, and then down at the bottom I need to choose a planar frame analysis. And again, this is the only kind of analysis that we'll be asking you to perform in this class. And then I click apply. And I get a little success message down here. If this says analysis unsuccessful or failed or some error appears, that means you have to go back and check your model carefully. What about results? Well, if we go to the results menu, we can look at diagrams. For example, the deflected shape of the member. I can click apply. And here the blue line indicates how this vertical cantilever has bent over to the right under the action of this horizontal wind load that I've modeled. We could get the nodal displacements, for example, at the top, node 2, and see that it's displaced in the x direction by about 0.864 inches. And we can look at the moment diagram. That's under diagrams, and moment z is the bending moment that you're going to want to be looking at in this class. So I select that and then click apply, and I get a moment diagram here. One thing that makes the moment diagram a little nicer to look at is clicking this fill box right here and then choosing apply again. And here we get that characteristic shape of the bending moment diagram that corresponds to half the shape of the Eiffel Tower.